Hi everybody, here is section 1.5 and this will be the last notes that we take for this unit. We're going to talk about the shape and spread of data. So kind of getting into the nitty gritty of, what we can say about the box plot or the histogram after we create it or when we analyze it. So I'm doing it over 2 different pages. There's no pre-made notes. You've just got to write it all down. And with this first one, I'm going to write some stuff right here. So you want to make sure that you're leaving that space blank while we're going, or giving yourself a little column while we're going through these. Okay. So skew left. What does that look like? Well, we're going to the left versus skew right. Can go to that way. My mom never taught me directions, so I blame her for some reason, and I think I should help you in case your parent did not teach you. I'm working on it. Okay, so for skew left, the data is grouped towards the minimum. And I think pictures can be really helpful. So you'd have a histogram that might look like this. So we're just drawing the axes, and they would be really high up here towards the smallest one, and then maybe get shorter towards the right. For a box and whisker plot, you would have a whisker and then your IQR, or your Q1 to Q3 would be towards the left or the minimum, and then your whisker would be out farther. So skew right is the opposite. So you've got data grouped towards the maximum. And so the histogram might start out short and then get big. The box and whisker plot would be towards the right-hand side. And so for these two, what I want to write over here, and I was talking to a colleague, and really for everything, you want to say that median is the best measure. So, the median does not take into any outliers, anything really small or really big, and just says, half of the data is above, half of the data is below. So when you're looking at articles or magazines and they're giving you this data, if they give you the mean, they're not always telling you, or the average, they're not always telling you the full story. The median is usually the best measure of data. So then we have symmetric. So data falls the same on both sides of the mean. Falls same on both sides. And that, you know, takes into account our lovely bell-shaped curve that we all know and love. So our mean, we remember that from our note symbol, is the same kind of to the left and to the right, they fall, you know, if there's 10 scores over here, there's about 10 scores over there. You know, obviously, if I'm a teacher, I want my test scores to skew right. I want most kids to do really well. So wanting the bell-shaped curve is kind of, you know, not always true. And then another symmetric that you don't see very often, but just to point it out, you know, if the mean is here, it might look like two mountains, something like that. But you don't usually see that too often. That leads us into normal distribution, which is a type of symmetric, and that's going to be our bell-shaped curve. And you will hear this in other statistics classes and even in, you know, college classes when they're talking about how they curve the test. It's just like the picture above. Here's your mean or your average, and it just seems like this nice, the same number of scores are above the average than below. And so for these, the mean or the median is the best measure. All right, so I'm gonna flip it over for spread. Maybe stretch some legs, take a break for the second part of our notes. And then we'll have one example. So spread is really how data spreads across the number line. Okay, so these we've talked about before. So range, so I'm gonna write the description. Sometimes I leave out vowels. So we have max, take away min, and if you need the picture or the image, you've got some box and whisker plot of whatever shape, and your range is from the two whiskers. Then you've got your interquartile range, or your IQR. So that's going to be Q3, take away Q1. And really the only time you can see this is your box and whisker. So again, you've got a simple whisker plot here. And you know, that just shows 50% of the data is within this margin. So your IQR is right there. Interquartile range. And then your outliers. So your outliers are like your super tall basketball player compared to the rest of the population, or a super strong person with muscle mass compared to everybody else. So values that just don't fit. And so you're looking at a histogram, and you might see, again, they usually touch. So you might see these bends with the frequency of whatever, and then you see this outlier right here. So something didn't work if you're in a science experiment, or that person was just way off, or really awesome. And then a box and whisker plot. You've got all of this way out here. And those might be the outliers. We can shade this if we want. Things that can just stand out in the range. All right, let's talk about a situation. Or as I say to my child, situation. I don't know. So we're given this. Let's see if I can zoom in at all. So you've got taking a math test or your math test scores. And we've got the afternoon and the morning. So the sun's coming up, the sun's already up, and the sky's bright. So these are our test scores in the afternoon, and these are our test scores in the morning. So right away, when we're having to start with an argument, we look at this data and, you know, most of all of this is skewed above or moved above the afternoon. And, you know, you think about it logically, most people when they're in the morning, they're awake, they're ready to go, maybe by not by 8, but maybe by 9. They're rocking and rolling, they've had their breakfast and everything's fresh. The afternoon, you've had lunch, you've forgotten what you studied last night, so you don't do as well. So when should you take your math test? Well, let's just talk about the shape and spread of both of these. So I'm going to say shape, and again, you can just sketch this out. You can do it, and spread. Okay. So if we're looking at this one, you know, I feel like if this is 75 and this is 95, so that's about 20 points. This is 75 and this is 55. Again, 75 to 55 is 20 points. So I would actually say it's symmetrical. And you can make an argument that it's skewed left because within the interquartile range or the IQR, it's towards the minimum. So I would accept both or skew left. This one to me looks pretty symmetrical. This is a little bit bigger, but when you think about where these are in relationship to both of them, I like to think that this is symmetrical too. So this is about maybe 87 to 97, so 10 points, and 87 to about 70. So you could, I mean, I guess I would call it symmetrical or I'd skew it right. And these can be arguments. So as long as you're using vocabulary and talking about shape and spread, you make a good argument, unless your analysis is that it's, you know, something that's not true. So what about the spread of this data? Well, so if I'm looking at these three, you know, the range, the interquartile range, and then the outliers when I'm thinking about spread, this has a large range right here. So lots of variability. Someone could get a 55 and someone gets a 95. and anything in between. And then for this one, when we're talking about spread, we also kind of take into consideration the median here. Like, how is that in terms of all the other data, and how does that compare to the one above? So I definitely want to say that this one has the higher median. And it has a smaller range. So the question is, when should you make your math test? And again, oh, sorry about that. So again, your argument is what's important, not whether or not I agree with it. It's whether or not you're using the shape and the spread. So you're looking at these words here for spread and these words here for shape. Okay? So I would say, and again, you can pause this and try for an answer and then look back. So I would say 2 sentences are pretty much what I'm looking for. So I want to take the test in the morning. Because the range is smaller. The median is also higher, or the median test score higher in the morning. And again, I want you to talk about it. So you could say both times the shape is symmetric. Or close to, maybe close to symmetric. So maybe that's not a part of your argument, but you're communicating to me, your teacher, that you understand what's going on. So again, these are examples that you can use on your test, or you can look at to help you with your test.